Morning everyone, thank you for joining Mr. Ish for today's video on inverse hyperbolic equations. I will continue where I left off with the other video on hyperbolic functions by stressing more on how we can solve hyperbolic equations. Remember, if you have a scientific calculator and you have these functions displayed on your calculator, these questions are very easy. But still, it doesn't hurt to learn how to solve these questions without the hyperbolic functions on your calculator. You'll still use a calculator for the basic calculations, but the ability to solve something like this without the benefit of those functions is a great asset. We have a question over here. 5 multiplied by the hyperbolic cosine function of x is equal to 8, and we have to solve here for the value of x. Simple, just take everything on the other side. You get an 8 over 5. But I would like to see this in a decimal form. It will be easier that way. 8 divided by 5 gives me a 1.6. So in essence, what we're saying now, if you did the hyperbolic cosine function of a certain value x, you should get 1.6. We're working backwards over here. Similar to the type of question we saw before we ended the previous video. So how do you go about proceeding over here? Remember, think back to the cosine hyperbolic function formula. You're going to go proceed this way. E to the x plus e to the minus x over 2 is equal to 1.6. Take 2 on the other side. E to the x plus e to the minus x is equal to 3.2. You have a denominator over here. You can see e to the x plus 1 over e to the x is equal to 3.2. Common denominator e to the x, right? 1 goes in e to the x times. It multiplies with this numerator. You get e to the 2x. Remember, laws of exponents. Plus 1 is equal to 3.2. Take e to the x on the other side. You have e to the 2x plus 1 is equal to 3.2 e to the x. Bring everything on one side, make it a quadratic function. Similar to a quadratic function. E to the 2x minus 3.2 e to the x plus 1 equals 0. Substitution technique. Let u equals e to the x. What do you essentially have? We have u square minus 3.2u plus 1 equals 0. Here we're solving for u using the quadratic formula. If you plug this a, this b, which is minus 3.2, and c into the quadratic formula and you solve for u, you should get two answers. You will get 2.848 as one answer when you plug them into the quadratic formula. Then you will also get 0.351 as your other answer, 0.351. But remember, here u is equal to these two values and u is equal to e to the x. So now when you actually solve for e to the x, you can see e to the x is equal to u, which is equal to these two. You got to natural log these values. X is equal to the natural log of 2.848 and the natural log of 0.351. You know, these questions take a little bit of a space, but when you do the actual natural logs over here, you'll end up with two very viable answers. Those answers will be, if you bring out our calculator, 2.848 natural log, I get a 1.0466. That's my one answer, natural logging the top quantity. 0.351 natural log it, I get a minus 1.0466. So you can say in essence you have two answers, plus and minus 1.0466, or you can round it up. But these appear to be two very good answers for this. And remember, just like trigonometric functions can yield positive and negative roots, you can also get them for inverse hyperbolic functions, especially when you're solving them out. So always be on the lookout for two possible answers. So when you carry this down to this format, you end up with two good answers. You could plug them back into this formula over here in place of x. You could individually plug these here in place of x, and you can solve them out and you get 1.6. I want you all to focus your attention to this question. Hyperbolic tangent x squared equals 3 over 4. Proceed as you normally would by opening up this tangent function, hyperbolic tangent function. You can say sine h square x over cosine h square x is equal to 3 over 4. Now the fun part is you actually have to plug in the definitions of these sine hyperbolic and the cosine hyperbolic, and you can do that. You can say e to the x minus e to the minus x over 2 square this right here is the cosine h, and then let's do the cosine, that's the sine h, let's do the cosine h, e to the x plus e to the minus x over 2 and you square it, all of this equals 3 over 4. When you open all of this up, naturally the 4's here, the 2 squares which are 4 will cancel out. So we can just omit those right away. Now we still have to open up these parenthesized aspects. What are we going to get? We'll get e to the 2x. Remember this right here is the top part, the numerator I'm looking at right over here. You'll get minus 2e to the x, e to the minus x, plus e to the minus 2x. Now let's look here at the denominator, the cosine portion. We're going to, remember these are here 2's which are cancelled out. You'll get e to the 2x plus 2e to the x, e to the minus x, plus e to the minus 2x. All of this equals 3 over 4. Think back to what I mentioned yesterday. You have an exponent base with an exponent multiplying by its exact reciprocal. They can essentially cancel out. So you essentially just get a minus 2 and a plus 2 over here. But I want you to look here, cross multiply everything over here. Multiply this way, multiply that way. Here on this upper side, you'll get 4e to the 2x minus 8. Remember 4 times minus 2 is a minus 8. Plus 4e to the minus 2x is equal to, all of this strand over here is going to multiply with 3. You'll have 3e to the 2x plus 6 plus 3e to the minus 2x. Let's get all these exponential aspects to one side and get the numbers onto the other side, the constants. This 4e to the 2x minus 3e to the 2x will just give me a plain e to the 2x. This 4e to the minus 2x will get affected by this. It will come out of it. You'll get plus e to the minus 2x. 8 will go on the other side to give you a positive 14. Let's make a denominator over here. E to the 2x plus 1 over e to the 2x equals 14. Common denominator, e to the 2x. 1 goes in e to the 2x, 2x times e to the 2x times. So you get e to the 4x plus 1 is equal to 14. Multiply this up over here. You get e to the 4x plus 1 is equal to 14 e to the 2x. We're now heading towards a quadratic equation. Bring everything onto one side. Let's do it. I'll get e to the 4x minus 14e to the 2x plus 1 equals 0. A substitution is needed over here. This right here is my substitution. U will equal e to the 2x. Not e to the x, but e to the 2x. E to the 2x. Now let's do our substitution. You get u squared, because e to the 2x times e to the 2x gives you e to the 4x. Therefore, u times u gives you u squared. Minus 14u plus 1 equals 0. Quadratic formula is needed. A, b, and c values. Remember the quadratic formula? You'll solve for u. U is equal to e to the 2x, which is equal to two values that you get via the operation of that quadratic formula. The two values that you get will be 13.928 and you'll get 0.0717. When you do minus b plus minus square root of b squared minus 4ac divided by 2a, you'll get these two numbers. But you have to understand u is equal to these two numbers. You still have to solve for x. In the process for doing that, 2x is equal to a natural log of these two numbers. 13.928 comma 0.0717, and you know that x is equal to all of that divided by 2. So let's get those values over here. You can do the individual natural logs of these and you're going to divide them by 2. I'll do 13.928 natural log it and I'll divide it by 2. I get a 1.317. I get a 1.317 as my x value after I run it through this operation. Then let's do 0.0717. 0.0717 natural log it and divide it by 2. I get a minus 1.317. I get a minus, same. But so we're getting two answers, a plus and a minus version. Plus and minus 1.317. And these are the x values. If you were to plug them in over here, in places of these x's and run them through, you'll get a 0.75. If, of course, you square them too as you're operating on. But these are the values you would substitute back into the original equation to prove that this side is equal to 3 over 4 and that side is equal to 3 over 4 and that your solution is correct. But you can see this was a bit of a more of an elaborated process. It required a slightly more bigger substitution. You didn't have the usual u equals e to the x, you had u equals e to the 2x, which created here an extra step of dividing everything by 2 to get your final plus and minus answers. Look at this question over the hyperbolic of sine function root x is equal to 1.5. And you could look at it as this way. You're doing root x is equal to the inverse hyperbolic sine function of 1.5. and x would therefore equal to the square of all of this because you're taking the root on the other side. So this right here represents the framework by which we have to tackle this question. And you can proceed as you normally would using the basic hyperbolic sine function definition. This one right over here, e to the x minus e to the minus x over 2 is equal to 1.5. Take 2 on the other side, e to the x minus e to the minus x is equal to 3. And remember, this square can come in at the very end. The effect of that square can come in at the end. E to the x minus 1 over e to the x is equal to 3. You know which direction we're leaning towards here. You'll get e to the 2x minus 1 is equal to 3. Take this up over here. You'll have e to the 2x minus 1 is equal to 3e to the x. Bring everything on one side. So we have a proper quadratic function going on. 3e to the x minus 1 equals 0. U should equal e to the x. So you can do a substitution. It becomes u squared minus 3u minus 1 equals 0. You can run this through via the quadratic formula. A squared, using the a, b and c, the minus b plus minus square root. I guess I'll just write it out here. Minus b plus minus square root of b squared minus 4ac over 2a. What's my a value is equal to 1. What's my b is equal to minus 3. What's c is equal to minus 1. And you know all of this is going to equal to u, which is equal to e to the x because of this substitution we've made over here, right over here, this substitution. When you solve this out, you end up getting two answers. What are the two answers you get? Well, you're going to get this as one answer. You're going to get 3.3 as one answer. But the other answer you're going to get is like a minus answer. It'll be a minus 0.302, I believe, minus 0.302. But when you solve for the x, you're going to do the natural log of these numbers. You can't do natural log of a minus, so this eliminates. So just technically, you end up with u is equal to 3.3. Bring out your calculator and let's do e to the x is equal to 3.3. So x is equal to natural log of 3.3 to give you your proper final answer. Bring out your calculator, do 3.3 natural log and I get 1.1939. But I'm getting x is equal to 1.1939. But I'm forgetting about this whole effect that we are talking about root x over here and then we have to take the root on the other side and square it. Therefore, your final x, you can say just final answer, is equal to 1.1939 square. What are you going to get when you square that answer? I get a 1.425. 1.425. Here is your answer, which represents x. 1.425. Look at this question. 4 multiplied by the... Now here's the difference. I would normally have had a sine h here, but I have a inverse sine h. X equals 7. So here you have to do a little bit of a out of the ordinary maneuver. Normally you would be thinking of a question which looks something like this. 4 sine h of some letter is equal to 7. When you solve for that, you're bringing in that. But here we already have, you'd be bringing in the inverse function. Here we already have the inverse. How do you proceed with this? This is how I would. X is equal to 7 over 4. Let's get a decimal number over here for 7 over 4. What's 7 over 4? 7 divided by 4 is 1.75 equals 1.75. This is not going to be a hard question. It's actually an easy question. Now you're thinking this. Look at this. Two ways of writing the same thing. Normally, if you took the hyperbolic sine function at 1.75, you would get some number x. But the inverse of that x would give you that 1.75. So you're basically looking at it in this way. It shouldn't be hard at all. Contrary to that formula equaling 1.75 here, the 1.75 is plugging into your places of x because the question is already providing you the inverse. It's already providing you that inverse answer. You're going in the other direction. So this is how you do this question. E to the 1.75 minus e to the minus 1.75 over 2 to solve for what your x is. You got to solve this out. Let's bring out that calculator and do it. Let's start with this. 1.75 minus inverse shift e. I get a 0.17. I have to minus that from this right here. Plus 1.75 shift e, natural log, shift natural log of course, divided by 2, I get a 2.79. I get it, 2.79. So here what you ended up doing was working in the opposite direction to how we have been so far for these inverse questions. You're working in the opposite direction. So 2.79 is your answer. Not a hard question. It may have seemed harder than what it is. But here you have to do exactly reverse of what you might have been thinking, because here the question was worded differently. You had the equation in the form of the inverse and you're working in the other direction. Normally I've been presenting you questions in the form of the non-inverse and you're using the inverse. Here the inverse is provided and you're working back into the non-inverse direction. So keep such tricks in mind, or such trick questions in mind. This question over here may seem to be difficult, but it actually isn't. If you bring the cosine hyperbolic function onto one side and take the number onto the other side, this is what you get. You get sine hx over cosine hx is equal to 5 over 8. And you know that's 0.625. This here represents a tan hx, but you don't have to convert it to tan hx. Work with this using your definitions. E to the x minus e to the minus x over 2 is equal to, now the cosine h part, e to the x plus e to the minus x over 2. These 2's will cancel out if you were to flip everything around, is equal to 0.625. Take this entire line over here and multiply it up over here. That's how I would do it. I would get e to the x minus e to the minus x is equal to 0.625 e to the x plus 0.625 e to the minus x. Bring all of this onto this side of the equation. You have e to the x, which will minus from 0.625 e to the x. You'll get, what will we get? Let's bring out the calculator. 0.625, you get 1 minus 0.625, 0.375 e to the x minus, you have a minus 1 over here, coefficient of minus 1 will add with this 0.625, because 0.625 will change sign to minus 0.625. So you get minus 1.625 e to the minus x is equal to 0. Because you've taken everything over here, you left nothing here, nothing is represented by 0. Look over here, we can do a denominator. 0.375 e to the x, and you can always do a denominator when you have a negative exponent because you have a reciprocal effect kick in. 1.625 over e to the x is equal to 0. We have this common denominator here, e to the x, e to the x. 1 goes in e to the x times. So you get 0.375 e to the 2x minus 1.625 equals 0. Take e to the x on the other side and zero it out. You get 0.375 e to the 2x minus 1.625 equals 0. Take 1.625 on the other side. 0.375 e to the 2x is equal to 1.625. Now the easy part of calculating a value for x. You're going to divide 1.625 by 0.375. 1.625 divided by 0.375, I get a 4.333. E to the 2x is equal to 4.33 repeating. Now you just have the simple task of solving for x. So you're going to take the natural log. Remember, 2x ln e is equal to ln 4.333. You'll do 4.333 and you'll natural log it. Then you'll divide it by this 2 because it would have been a 2x. But to take x, to solve for x, you take the 2 on the other side and divide it. Divide it by 2 and you get a 0.73316. I'll do that as a 0.7332. Easy. Remember, e to the power of 2x is equal to 4.33. You have to bring this exponent, binary exponent down here as a coefficient and bring the natural logs. So 2x natural log e is equal to natural log 4.333. X is equal to natural log 4.3333 divided by 2, and you get this as your final answer. And we are done with this question. I want to present here an interesting question. I believe you'll find this to be quite interesting. Hyperbolic sine square x plus hyperbolic cosine square x is equal to 5. May seem a little tricky at first, but just proceed with it as you normally would using your individual definitions. And let's do that. E to the x minus e to the minus x over 2. Square this. That represents the sine h squared component. Here's your plus sign. Let's do the same with the hyperbolic cosine function. E to the x plus e to the minus x over 2. Square this is equal to 5. When you open all of this, you'll find very conveniently things will cancel out. It won't be hard. Let's open this top part. We'll get e to the 2x minus 2e to the x e to the minus x plus e to the minus 2x over 4. Open this next part, e to the 2x plus 2e to the x e to the minus x plus e to the minus 2x over 4, all of course equaling 5. Common denominator is seen. Let's extend the common denominator all the way across. Unify it. Unify it all under this 4. Can we calculate this further? Yes, we can. We can do that by cancelling things out. This cancels out right here with this. You are left with 4 terms which are common terms, 2 pairs of common terms, and we combine them. When we combine them, e to the 2x plus e to the 2x, we get 2e to the 2x. E to the minus 2x plus e to the minus 2x, we get plus 2e to the minus 2x. Remember, like terms adding together doubles, right? Divided by 4 is equal to 5. Before I do anything else, I want to start simplifying things here. I have here everything even numbers, 2, 2s and 4s. If I cancel out the 4 and I make it a 2, I can cancel out these 2's into 1, because all of these are being, you could say I took this entire part and I multiplied by half. The 2's became 1's and the 4 became a 2. Nothing wrong with doing that. Take the 2 on the other side. You have e to the 2x plus e to the minus 2x is equal to 10. We're beginning to have something take form in the shape of a quadratic equation. We have a fraction we can develop over here. E to the 2x plus 1 over e to the 2x is equal to 10. Remember, this right here is always 1. Something is always over a 1 if there's no fraction. It's generally divided by 1. A convenient trick to remember. Let's do a common denominator over here, which will be e to the 2x. This 1 will go into e to the 2x, e to the 2x times, so you'll get e to the 4x plus 1 to give you a 10. Now all you gotta do, take this on the other side, you get e to the 4x plus 1 is equal to 10 e to the 2x. Bring this 10 e to the 2x and let's complete a quadratic equation over here. Quadratic function over here. E to the 4x minus 10 e to the 2x plus 1 is equal to 0. A substitution is needed over here. You can see that let u equal to e to the 2x, because we have e to the 4x, we have to use e to the 2x over here. E to the 2x times e to the 2x gives you e to the 4x. Therefore, by same measure, u squared will give you that, minus 10u plus 1 is equal to 0. Now you know exactly what you gotta do. A quadratic formula. Let's make our writing neat. U squared minus 10u plus 1 equals 0. You have a, you have a b, you have a c. You hit it by the quadratic formula. When you hit this by quadratic formula, you get u, which is same as e to the 2x, to give you 2 numbers. What are those 2 numbers? Let's calculate them here on our calculator. You got a, b, and c. I'm going to work this here on my calculator and present you 2 numbers. I'm going to get 100 minus 4 square root of that. I'll get 10 plus square root divided by 2. I get one number is 9.989. Remember, the more numbers, actually 9.898. The more numbers you put over here, the more accurate your answer. So always take a balance between how many digits you want to put and accuracy. So it's a delicate balance between those two. The other number you'll get will be, let's see, 10 minus the square root of all of that, the b squared minus 4c divided by 2a, and I will get 0.101. 0.101. You know, of course, e to the 2x is equal to all of that. So therefore, 2x is equal to the natural log of those numbers, which is 9.898 and 0.101. We're doing natural logs of these, then naturally x will equal to all of this divided by 2. And all of this is of course separated by a comma because we're working at 2 numbers at a time. Let's do 9.898 natural log and divided by 2. 9.898 natural log divided by 2, I get a 1.146. 1.146. Let's do 0.101. 0.101 natural log it and divided by 2, I get a minus 1.146. So I'm getting 2 solutions, or a plus and a minus 1.146. So my actual solutions here for x are plus and minus 1.146. This represents my answer over here. You plug these in places of x's over here. This all will equal a 5, which will of course equal the 5, and you'll end up proving that your answer is true. So this process was not hard. May have been a little cumbersome, may have been a little messy and work, but you end up with a final answer, and that makes it all worth it. I'm going to present one last example for this video, and that will wrap us up for today. Here is our last question. Look at it. Inverse hyperbolic sine function of cosine h is equal to 2. Looks a little tricky the way it's written out. Maybe it looks a little confusing too. At first, it may appear confusing, but if you think about how we look at these equations normally, it might actually help. Wouldn't this be same as saying sine h of 2 was equal to some value, and that some value was cosine h of x? Think about it. This right here is the same way as saying that. You're trying to find the inverse hyperbolic sine function of cosine h, which was giving you 2, but the sine hyperbolic sine function of 2 was giving you cosine hx. So this exactly is rewritten in this form, and this form right over here tells you exactly how you will lay out your equation by plugging in your basic definitions over here, and then you will see it'll actually be a very, very easy question. Let's put the basic definition for sine h. You'll have e to the x minus e to the minus x over 2 is equal to the definition of cosine, hyperbolic cosine, e to the x plus e to the minus x over 2. But now think back to the first video I presented on hyperbolic functions, where I showed you these type of questions, the basic questions. When you were trying to find the hyperbolic function of a number, all you had to do was replace the x's with that number or the quantity you were given. So that's all you gotta do over here. It's actually e squared minus e to the minus 2, because this 2 is represented here in place of x. Look over here, you got divide by 2, divide by 2. These would eventually cancel out, so cancel them out right over here. You essentially now have e squared minus e to the minus 2 is equal to e to the x plus e to the minus x. These right here are your x values you have to calculate. This right here is the entire numerical quantity. You can calculate it right here on your calculator. E to the power of minus 2, hit 2 to the power of minus 1 and shift natural log. Minus that from this quantity right here. What do I get? I get a 7.2537. The more decimal places you write here, the more accurate your final answer will be. But I'll keep it 7.2537 now is equal to e to the x plus 1 over e to the x. Remember, reciprocal brings out a fraction to a common denominator, e to the x. 1 goes in e to the x times, you get e to the 2x plus 1. Remember, most of these questions will end up involving the quadratic formula, because you end up creating a quadratic equation. The ax squared plus bx plus c. Bring this over here in a multiplying format. You're going to get 7.2537 e to the x is equal to e to the 2x plus 1. If you bring everything on one side and equal it 0, you get this e to the 2x minus 7.2537 e to the x plus 1 is equal to 0. Here's my a is actually coefficient 1, b is a minus 7.2537, and c is equal to 1. These will plug into your quadratic formula. Before we do that, let's make the substitution. U is equal to e to the x. Therefore, your equation is u squared minus 7.2537 u plus 1 equals 0. This u looks more like an O over here. Make it better, u. Do the quadratic formula, easy. And you'll get 2 answers for u's, which will represent 2 answers for e to the x because of that substitution you made. By virtue of that substitution, you'll have to solve out for 2 answers. When you plug this into the quadratic formula, you get 2 numbers. The 2 numbers that you get are, remember, the more decimal places you use, the more accurate your final answer, but I have a limit here to the number of decimal places I'll use. And I'll get a 0.1402. E to the x is equal to both of these, so x will equal to the natural log of both of these numbers, 7.1127 and 0.1402. Now, a very simple matter of doing calculator. You get 2 answers. Let's do these individual natural logs, present 2 answers. 7.1127, natural log it. I get a 1.9618. I get a 1, actually let's round it up, 1.962. I get a plus 1.962. Let's do 0.1402, 0.1402 natural log it. I get a minus 1.962. Round it up, of course. So you have 2 solutions. positive and minus 1.962. These are your values for x. If you were to plug them here in place of your original function, right, you can even look at this as your original function right over here. If you were to plug in positive and minus 1.962 in place of x over here, which would fall in place of these two x's over here, you'll get sine h2 to equal cosine h of that substituted value. So these are right here the techniques for solving inverse hyperbolic functions. You consider they're techniques for solving hyperbolic functions because these techniques involve the use of inverse hyperbolic functions. Knowing both forward and backward direction is essential to these techniques. Not having a calculator with these hyperbolic functions is actually, in my opinion, a plus, because you're forced to learn this technique. But if you have the calculator, this whole technique is narrowed down to a bunch of calculator strokes. I hope you enjoyed this video today. It could have been a little technical, or it was technical, but you can watch it a few times. You can take stills of these just to see how the process was in a more slow motion format, and just look over them as you need. But please like, subscribe and share. Thank you for watching this video. Have a nice day. Bye.